All right, 19.3, when we were talking about waves and sound, we talked about the ear, and now we're talking about light, so we're going to talk about the eye. So, right in front of you here is a great diagram of what your eye looks like, and we're going to talk about the little different pieces of your eye here. You have the cornea. Now, the cornea is the covering of the eye. It's the protection of the eye. This is what keeps everything out of your eye, the sand, the grit, etc. It protects it from getting hurt. Then you have the iris. That's typically the colored part of your eye. And behind that, you have the lens, and the lens is what helps you focus light. Now, one crucial thing here is you have two muscles. All right, you kind of have these muscles that help your eyes focus. When you squint, all right, anyone squint? If you squint right now, you can typically see a little bit better or closer, things that are closer up. That helps change your focus a little bit. Typically, the reason your eyesight gets worse the older you get, unless you're rhesus and you're already wearing bifocals, is the idea that just with age, your muscles get weaker. When your muscles get weaker, they're not able to hold that lens in tight and help focus things crisply. So typically that's why as you age, your eyesight gets worse because those muscles in your eye get weaker. They have a harder time focusing. So your cornea, again, protects your eye. You have your iris, and then behind your iris you have the lens, which is what's focusing the light. On the back side of the eye, you have the retina, right, which is kind of holding the eye in place, everything kind of together a little bit in the eye socket. All right, the retina is holding everything together. And then you have the optic nerve. The optic nerve is what focuses light. What's interesting is you'll notice that the nerve, or sorry, not the nerve, the image is upside down, and when the nerve transmits that, your brain has the ability to flip that right side up again, which is actually incredibly neat. So what you can see here is on the back side of the eyeball, everything is focused perfectly. See how this object meets crisply and clearly right on the back side of the eyeball? If that happens, you have 20/20 vision. You want the object to be focused perfectly right on the back side of the optic nerve. Now, if that's not the case, if the object is focused in front of the optic nerve, you are nearsighted. All right, anybody nearsighted? See our gap here? It should be focused here, and see where that Christmas tree is? It is definitely short, so it is nearsighted. Then go to the other eye here, and it's said it's focused beyond the optic nerve. When it's focused beyond the optic nerve, you are farsighted. Do we have anybody who's farsighted in class? All right, I am nearsighted. So I have the ability to see things real close, but not very far away. If you're farsighted, you can see things very far away, but not up close. And that's because in nearsighted, the object is focused in front of the optic nerve. And in farsighted, it's focused behind the optic nerve. Again, if you have perfect 20/20 vision, the object is focused directly on the optic nerve. So nearsighted, farsighted, and a little bit about information about the eye. Now, your eye, last thing about your eye is incredibly deceptive. It is very easy to trick your eye with color or an illusion. Right? Your eye, even though you depend very much on them as human beings, can be tricked very easily. In fact, of all the senses, it's the one that probably can get tricked the easiest out of all of them. So we are going to talk about some optical illusions and different things about your eyes in class tomorrow. But that is all I need on section 819.3, the human eye. This is Mr. Clennert, and I am signing